So here we're given this relationship between s and t, and we're told that the value of s increases by 50%. So that becomes, let's say, 1.5s, and k remains the same. Say this is the new value for the t. What happens to t? So if I move this here, 1.5s times t new is equal to k, and k, if I manipulate this, is s times t. So I'm really interested in how does t new compare to the original t. You can forget about the k part, which is both equal. Divide by s, so we get t new is t over 1.5. So the original. So the question is, what happened to it? What's the change, the decrease? It was earlier t, drop to that. So the change is t minus t over 1.5, which is 1.5t minus t over 1.5, which is 0.5t over 1.5, which is 1/3 t. And that, as a fraction of the original, gives me a 1/3 change, which is really 33 and 1/3%. And just keep in mind that that's a decrease. And that's answer choice B. Now, you could do it with numbers as well. I mean, for example, let me see how you do this with numbers, because I do have students who kind of do struggle picking numbers and following the process. So the way you want to go about that is if, let's say the initial value is 100. So k is 100 times t. They say d increases by 50%. So s new is 150. So that relationship remains. 150 equal to k over t new. So then you would say 150 t new is equal to k, which is 100 t. So t new is 100 t over 150. And again, this becomes 2/3 of t. You can pick a value for t as well. I mean, t could be 100. Or if you want to make it a whole number, you could say initial value was 30. So t new is 20. It decreased by 10, which as a percent change of the original would be 10 over 30, which is 1/3, or 33 and a 1/3% as we obtained here. So you could go about that way too. The answer is B.